Okay, so now we're going to be working with radicals. Now radicals have a unique twist to them, and it is a way of thinking that I'm going to try to get you into today. We're going to be talking about two main things with the radicals have, and they are called, number one, restrictions. Okay? Not everything is allowed. So we're going to be talking about that, and the next thing is extraneous roots. Okay? Those are two new concepts today that there's a learning curve, obviously, right? We're going to spend today and tomorrow on it, and then we're done. Monday will be your practice test, and Tuesday will be your exam. So probably an understandable goal, I would say, is get your practice test done before Monday. Then you have all day Monday to be asking questions, going over. People say, hey, do you have any other stuff? I got other stuff. But, you get that done, and it just makes your week easier when you come back, okay? You always have to be thinking when you come back, too. Nothing sucks more when you just leave everything, and then you come back. It's like, it just hits you. And you get overwhelmed, you get stressed out, you get sick, blah, 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 right? So think about Monday and think, I want an easy Monday, okay? So math, we can do that because you're going to be, hopefully got your practice test done or 3/4 done, okay? You got all your questions. You're like, what? How did they get this? This is like dumb. I don't know what they did here. Where'd they get the 5? Okay? So where'd they get the 5 from? Okay? I can show you where you got the 5 from. So anyway, see if that's a obtainable goal for you. This is one of those exams that you'll be able to know if you got 100% before you hand it in. And quite a few of you will, right? So you're going to see that people are just going to keep climbing, and nobody wants to be left behind on that one and keep your mark in the 60s or 50s or even lower. So we'll just plant that seed, and hopefully we'll get a few more people ready for it. Now, today we're just going to be talking about the square root equation. Now, that's the most simplest square root equation there is, square root x. Now, the thing that you guys have not been challenged with or has been kind of left aside, okay, don't let the little children see this, okay? Traumatize them forever. But now we're going to be talking about, hey, you just can't use every x you want to use. Now, what do you know about the x's that are in there? Okay, what x's are allowed in there? Can you take the square root of everything in the world? No? Well, so what can't you? What can't you take the square root of? Negatives. Now, the best way to say that is x has to be greater or equal to 0. That is the mathematical way of saying x has to be positive. No matter what, that thing underneath the radical sign has to be positive. And what do you think will be the numbers that come out? Positive numbers. Okay? So when you just have a square root, x is going to be, and then this one, y will be greater or equal to 0 too. And what you do is, so if you take square root of 4, it's like 2, right? So it's going to look like this. And this would be 4 comma 2. Where did I just pull that out of? Well, if the square root of 4 is 2. Put in my x as a 4, it's going to come out as a y of 2. Okay? So far so good. What about this one? What about this radical equation? What if you put in 0 in there? What's 0 minus 2? Negative 2. So for that one, would the domain be x is greater? What would the domain for that one be? X would have to be greater or equal to 2. what would be the range? The diploma loves domain and range questions. They love it, right? So if you hate it, learn to love it, because that's what's on the diploma. What would be the range of this one? If you put numbers in greater than 2, like 2.000001, what would y be? The square root of 0.000001. It'd be pretty tiny, right? So I'm not allowed to do anything less than 2, so I would get something like this. I would get this kind of graph. See, all my y's will still be positive. How can you get a negative y there? Right? I mean, everything that comes out of that equation is going to give you, okay? So today is a lot about kind of thinking about the, what's wrong? Don't understand? Well, this is x is greater or equal to 2, so I put that there, right? So that's where I got the 2 from. Now, why does it just go from, so if you put in, say, let's go 6. If you put in 6 into here, square root of 6 minus 2 equals square root of 4, which equals 2. So you could have like 6, 2 would be your point there. Okay? So, but there's no way, there's not a number I could put in there that's going to equal anything less than 0. Okay? If I put in 2, what is, I'm going to even verify this point. Square root of 2 minus 2 equals 0. So when x is 2, y is 0. Does that help? Okay, cool. Okay, so now I'm really going to mess with you, because we're going to try and find domain and ranges with some more kind of difficult ones. Okay? And again, domain and range, that's all you get in grade 12. It's all you get in the diploma. Okay? So if you get to the diploma and you're like, domain and range, what's that? Oh, I suck at those. I've never been able to get good at them. Okay? That little conversation you just had with yourself should never happen. Okay? And I got to make sure it doesn't happen. Now this one here, right away you want to get solving it. Don't. It doesn't ask for the answer. It asks for who's allowed to play. What x's are allowed? Now, what you look at is anything under a square root sign. What do we know about that red little circle, well, whatever, oval? The stuff inside that oval, what does the outcome have to be? It has to be greater than 0, right? You can only take the square root of x is greater or equal to 0, right? So, look at this statement. Does 4x plus 1, does all of that have to be greater or equal to 0? Does that make sense? Okay? So that's how you start. You go, well, 4x plus 1, like, all of that has to be positive. Because remember, this, that means positive. Greater or equal to 0, that is the same, that is the mathematical way to write positive x, or greater or equal to 0. That's positive. And if you're like, well, it doesn't, sometimes it doesn't work. Well, give me an example of something that is greater or equal to 0. That's not positive. Okay? And 0 is positive. Now, it says, well, 4x plus 1 has to be greater than 0. Yeah? Still doesn't help me. Like, how can I do my number, like, you know the number line? Everybody loves number lines, right? But I'll tell you, number lines really help here. So we're going to do number lines for these after we're done, so you can have a visual. Okay? Now, I'm going to do some algebra after I've done this. So I will minus 1 to both sides. 4x has to be greater or equal to negative 1. Then I'm going to divide by 4. X has to be greater or equal to negative 1/4. And then you get this statement here, x has to be in the reals. The little pitchfork there. X has to be in the reals. Now this messes with people. They're like, what? What do you mean x is in the reals? You just told me that I'm not allowed to use every number. I got it. X is greater or equal to negative 1/4. Now those two are always together. You just can't look at the second part and just isolate it and say they're contradicting each other. No, together they say, okay, I'm saying x has to be greater or equal to negative 1/4, and of those x's that you're using, they can be all in the reals. Okay? That's what that means together. If you take one sentence out of context, just that one sentence out of context, you can manipulate anything you want. Okay? So, same with this. Just don't take the one little part. They're the little team. Now, what does this mean? Okay? Well, let's look at a number line. Your number line goes like this, right? And here's 0. Negative 1/4 over here. Okay, with me? This says x has to be greater or equal to. So it is all of these. Now, why do we use number lines? Is it just another thing to make math more complicated? Well, it's not supposed to. It's supposed to make it easier. Because if I was to sit down and list all the numbers greater than negative 1/4, I'd be here for the rest of my life. And therefore, so would you, because I would make you endure that pain with me. Okay? Because I can't tell you, like there's so many, between the numbers 0 and 1, there's a gazillion, billion, willion numbers in there, right? That's just between 0 and 1. You give me any number between 0 and 1, I can give you one smaller than that that's still between 0 and 1. Okay? I'm not talking about all the numbers in the world, I'm just talking the ones between 0 and 1. So the graph says, okay, see how I circled it? Because that's greater than equal to. If you circle it and leave it open, that's just greater than. And my arrow goes to the right. That's saying all the numbers in the world greater than negative 1/4. And I would do a test. And when you do a test, do a number that's nice, not 0.3857162, okay? Pick the number 0 or the number 1. Do they work? Okay? If I put 0 in here, 4 times 0 is 0 plus 1. Okay, that's positive. I can take the square root of 1. That's not going to give me an error in my calculator. It's all good. Okay? So that's how that one would look. Okay? Now, B. You look at B and you're like, okay, whoa, there's a minus 7 in there. That's going to affect my domain. No, it doesn't actually. See, we don't want an error in our calculator. There will be numbers that give an error in our calculator. I guarantee you in A, put in anything less than negative 1/4. It's going to give you an error. Try negative 2. 4 times negative 2, negative 8. Negative 8 plus 1 is negative 7. Square root of negative 7, not going to happen. Any number less than negative 1 will give you an error in your calculator. Okay? Domain error, it will say. Why? Because that's not in the domain of the question. Okay? Well, let's do this one. We're going to do it the same way. I don't care about the negative 7. This part here, it's it controls the entire question. Because I got to make it happy, and the entire equation will be happy. Okay? So, I've got to say, well, 2 minus 5x, for this to be able to be solvable, has to be greater or equal to 0. Does everyone get that? I need this to be greater or equal to 0. I'm going to get an error in my calculator. So did I care about the 7? Nope. Just the stuff under the radical sign. So I'm going to now minus 2, minus 2, negative 5x has to be greater or equal to negative 2. Then I'm going to divide by negative 5. X has to be, what's that? Less than or equal to 2/5. You guys remember this? Okay. So I want to do a little commercial break here. Going on up. Okay, I just want you to watch. Because this is important. This is going to change your life right here. Okay? Now, all I'm going to do is write down statements, and you just have to say are they true or not. Because if you don't accept them, then this proof doesn't work. Okay. Is negative 4 greater than negative 6? Right? Because it's more right on the number line. Now, that messes with some of us for a bit there. No, 6 is way bigger than 4. The negative has some part in there. Right? Again, take it out of context, and this won't make sense. Does everybody agree with this statement now? Negative 4 is greater than negative 6. What if I took each of these and multiplied it by 2? I can take this, because in algebra, I get to do one side or the other, right? Is negative 8 greater than negative 12? Okay, so we're good, right? You guys believe that? Okay, moving right along. How about, I'm going to start with the same thing. So hopefully I don't have to get you to buy into that, because you did already. I'm going to divide by 2. Is negative 2 greater than negative 3? Got your buying in so far? Okay, cool. So I'm going to put a check mark because you guys say you agree with that. Now, what if I keep going? I got negative 4 is greater than negative 6. I'm going to divide by negative 2. 2 is greater than 3. It's not true, is it? To make this true, I would have to do this, right? Do you agree with it now? Okay. How about if I had negative 4 is greater than negative 6 again? I'm going to multiply both sides by negative 2. Is 8 greater than 12? No, so I got to reverse the sign to make it true. So, in the last step, when you're ever trying to solve for x, if you ever divide or multiply by a negative, always reverse the sign. Okay? Have you ever heard that before? No? None of you? Seriously? Okay, well, this is life-changing. Okay? And I proved to you why. So, you need a rule here. When dividing or multiplying by a negative in inequalities, always reverse the sign. Okay, and this is a common practice because you're going to do a lot of inequalities in grade 12 as well. Okay, so x has to be less than or equal to 2/5, and x is in the reals. Now again, we need a visual for that. Less than or equal to 2/5. Okay, so here's my line. Here is 0. 2/5 is on this side. And I go less than or equal to, and I put this in there. Okay, well, what? Like, I want to test that. 0. I know 0's in there, right? 0's shaded. I know that's pretty small. Okay, I didn't have much room. Okay, so that's 0, and that's 2/5, okay? So I try 0. Maybe 0 is a little lame. I'll try negative 1. Sometimes 0 messes with you, right? So negative 1, would that work? 2 minus, what's 5 times negative 1? Negative 5. 2 minus negative 5, same thing as 2 plus 5. I can take the square root of 7. So, you know how I've done anything less than 2/5 actually works there. And some people go, what? You told me I'm not allowed to put negatives in there. No, no. I said the thing underneath the radical sign is not allowed to be a negative. Answer. I can't take the square root of a negative 2. So the thing that I circled, as long as all of it stays positive, you're good to go. Okay? Now, just in case you're understanding this, let's move on to C. Because C has 2 inequalities in it. Just when we weren't understanding 1, now I have to not understand 2. Okay? But you will. Now the first one, can we do it just visually? What would x have to be greater or equal to for this? 2, right? So because 2 minus 2 is 0, I can take the square root of 0 and anything greater than that. How about the other one? X would have to be greater or equal to 4. Okay. Now remember, when you put, you're not allowed to put 2 different x's in when you solve. But I want to just let's kind of put our heads around this. Okay, so I got, here's 0. X has to be greater or equal to 2. So here's 2. So then I have this thing. Right? And then I have 4 over here. And it's this thing. Now the question you have to ask is, what? Like which one? Now if I put an x of 3 in there, could I solve this question? No, I couldn't. Because the 3 minus 4 is going to give me an error in my calculator. Square root 3 minus 4 is negative 1. Square root negative 1 not going to happen. So do you see that the more, 4, does 4 work for the entire equation? 5, 6, 7, 8. So do you see how the 4 is more to the right side? See, they're both pointing right. And I mean the direction right. They're both pointing the direction right. The one that is more right is the one you will use. So how are we going to write that down? If both are pointing right, choose the more right. I know this isn't the most scientific definition you've ever given in your life, but it works. Okay, and with that, if both are pointing left, pick the more left. So the answer for C is x has to be greater or equal to 4. X is in the reals. 3 is not allowed. 2.1 is not allowed. 2.8 is not allowed. 3.5 is not allowed. 4 and up is allowed. So these are little rules, things you're going to write in your study sheet that they're going to really help you do well on the test, right? And more importantly, in 3 months from now, when you have to pull this unit out, oh yeah, the equations unit, you read that over, all those things are going to come back to you. Okay? Now, let's do D. Okay? Now, what would you say? So we're going to look at this one. So x plus 2 has to be greater or equal to 0. So x has to be greater or equal to negative 2, right? Now, just doing some algebra, minus 2 minus 2. 3 minus x has to be greater or equal to 0. negative x is greater or equal to negative 3 so I got to divide by negative 1, don't I? So x is going to be less than or equal to 3. And think about it. Anything less than 3. Would 2 work quite well in that one? 3 minus 2 is still positive. You know, anything greater than 3 is bad. 3 minus 4, oh, got a negative. So see how it makes sense that you reverse that sign? And I don't know what you got to do, but you know what I always do, especially when I'm teaching it? I draw this arrow. And you're like, huh? Well, why is an arrow there? Because whoa, look, they changed. Why did they change? Oh, yeah, I divided by a negative. So if you're writing a written response for me, and you show me that, I'm like, okay, they got it. Or they kept it the same. They just said x has to be greater or equal to negative 3. I'm like, okay, they missed the point of that lesson. When you divide or multiply by a negative, in that last step, you got to reverse the sign. So, whoa, x is greater than negative 2, x is less than 3. Can you visualize what's going on here? If this is 0, I got 3 over here, and I got negative 2 over here. Like, who am I supposed to do? Well, the point is, everything in between here will work. If you're outside of that, it's going to give you an error in your calculator when you try and solve it. And do you see how I am less than 3 and I am greater than negative 2? So the way we write this and read it is we put our x in the middle and we read from the inside out both ways. X has to be less than or equal to 3 or greater or equal to negative 2. So you read from the inside out. X is greater than negative 2. X is less than 3. Less than equal to. And then x in the reals, right? Yes. That means anything now that I have said between negative 2, any real number. Okay, I'm allowed to use any real. Sometimes only integers. Like you guys can order any pizzas between 0 and 3. Well, you're not gonna. That's not reals. That's going to be integers. Actually, it's going to be natural numbers. You would say x is in the natural numbers because you can't order 2.8 pizzas. Okay, I mean you could try. It'd be really funny, ha ha ha. But they're probably going to hang up on you. Okay, so. Yep. Well, it said it has to be greater than negative 2, right? How did I know how to write that part or how to graph it? Because if there's 2 radicals, I have to do both radicals. That's what we had to do with C and D. With B, there was only 1 radical. With A, there's only 1. Okay? So if there was 5 radicals, I got to do it 5 times. I would never be that mean, though. Okay. Just in case you were understanding this, we're going to go all the way to page 268. Now we're going to talk about extraneous roots. Now, does anybody know what extraneous means? Like in real life, not mathematical. Anyone know what extraneous is? Huh? Extra long? No. Are you trying to say that this class is extraneous for you? No. If you're in the court of law, this comes up quite often, this word. So you're in court, okay? You got your jury there. You're the crown, right? The crown wants this guy. He's a murderer. Bad guy. 20 murders, right? There's your chance a lot, right? We finally caught him, though, after 20, right? And I'm trying to get this guy. He always gets out. He's got a good lawyer, okay? So he's done 20 murders, the whole thing, okay? There's the jury over there. Picture the jury. And I go to this guy, and I go, and I'm reading through my notes, and I say, Yeah, he's killed 20 people, but I got something better. It goes, and I have character witnesses or witnesses that will verify that he's really mean to his mom. Okay? Now the other lawyer will stand up immediately and go, extraneous, strike it from the record. And the secretary that's like burning away has to like go and like, okay? Because maybe he was, but that has nothing to do with proving that he was there doing these murders, those murders sort of thing. Because there's a lot of people that are mean to their mom that don't murder. Okay? Or they don't like their mom or whatever. Extraneous, it's not that it's false. It's just not allowed in here today. And lawyers bring up, or the Crown or the defense bring up extraneous information all the time. Now, is it because they're stupid? Is it because they love getting yelled at? Because the judge will say, agreed, okay, and then I have to like stop, and he says to the jury, you'll ignore that, and they move on. Now, why on earth? Because he's inexperienced. He's not smart enough to know that he shouldn't bring up stuff that's extraneous. Why do they do it? The jury will be affected. Okay? That jury's going to be in there deciding, and they're all going in the back, and he hates his mom. Ooh, we're going to get him. We're going to get him good, right? So when there's a jury, extraneous information is brought up quite a bit. And then it's shot down, but a jury just can't go, okay, that's gone. Let's go on, right? So they'll do that. And if they do it too many times, then they do get in trouble. Like they'll always pretend like, oh, sorry, I didn't mean to do that. My bad, right? But they're like, yeah, okay. And then they walk away and they say, you know what? I know the jury heard that. I could see by their facial expressions they didn't like it. Okay? Now it might not be something that, but they may say, where were you at this? And they'll lead questioning down a place that makes him look like he's lying, like he's manipulating, that sort of thing. And then the other lawyer will get it shut down, going, I can't see where this is going. This has nothing to do with this. I mean, this was 5 years in advance, whatever, okay? So, extraneous roots, okay, they are solutions that are not correct. Okay? Now this may seem like a pretty weird sentence. So an answer that doesn't work? What? What I'm trying to say is he probably is mean to his mom, and maybe they have some, it's not allowed in this courtroom. It's not allowed maybe in this domain. And you'll see what this means when we get to it. But after you solve it, always test it. If it fails the test, then it's not allowed. Okay? So I want to get right to one that illustrates this, not one that is like a gooder. I want one that... Look at this one. X minus 3 equals, or square root x minus 3 equals square root 3x minus 5. Now, how do I solve this? What's the best way to solve this thing? You can't. They're held captive right now. Right? You can't get those doing anything till you get rid of something. Square both sides. So you square both sides, okay? And the magic happens. Okay? Because if you square both sides, I get rid of square roots. Because these are opposites, right? Like I don't care what's underneath, it will equal that. Okay? The square root of 9 is 3. 3 squared is 9. get it right back. Okay, so if you want to have that as your example, okay, because square root of 9 is 3. 3 squared is 9. You can do the math every time, but then you're going to figure out, hey, when you square the square root. Now, if we do the math here, minus 3x. I'm going to minus 3x there and there. So I get negative 2x minus 3 equals negative 5. With me? Okay, then I'm going to add 3 to both sides because it's minusing 3 there, right? So I get negative 2x equals negative 2. See, I'm not looking for, what was I looking for about 5 minutes ago? I'm looking for x this time. I'm not looking for restrictions. Okay, I'm solving right now. So then I'm going to divide by negative 2, x equals 1. So x equals 1 is a solution. But maybe it's wrong. Or maybe it's extraneous. Okay, not really. So let's test it. Put it in. 1 minus 3, does that equal square root 3 times 1 minus 5? Well, 1 minus 3 is negative 2. 3 minus 5 is negative 2. Now at this point, people could say, it's true, square root 2 equals square root 2. But what's the problem? You can't take square root of a negative. These solutions don't even exist. Okay? So now do you see what a solution is that isn't allowed? Okay? Yeah, maybe he was mean to his mom. That's not allowed in here, okay? You just can't throw stuff in. There's inadmissible evidence. We told you it was inadmissible. Why are you bringing it back in, right? And sometimes you get held in contempt, and you can, like, there's bad things that happen if you keep doing it, right? But once in a while, if you slip up, right? So, we would say neither left side or right side is a real number. Comma, therefore, there's no solution. Because if 1 is the only solution, I'm not even allowed to use it because it gives me this negative number. That would be called, so I come back here, this is an extraneous root. Okay? So there's a little word that's nice to have on a study sheet, because I will have this conversation with one of you when we're doing the review for your final exam, and it's going to say, yeah, find the extraneous root. You're going to go, we never did these. Never did what? Extraneous roots. Like, I have nothing on my stuff, and we didn't do these. I know we didn't do these. And we did. And grade 12, they're going to come up too. And you're going to be like, did we do? I know. Because everything I asked you guys about last year, like, half the class are like, yeah, we did it. The other half class, no, never seen it before. Now, we're going to do one more, because this is an excellent question. Why is it an excellent question? Because it's hard, right? Now, I hated when I used to take math, and we'd do our notes just like this, and the teacher would do all these nice, easy ones, and then the homework would be like all these huge, complicated ones, where this one, right, is as hard, or the hardest one you'll see when you do your homework. Okay, so we do it together, right? So the first thing you always need to do is I would isolate the more complex radical. Now, we know what isolate means. It's like get it by itself. Okay? Now, isolating it's like isolating a problem. Okay? That's not as easy as you would think. Like, down the atrium, two guys get in a fight, right? So you haul them in the office, one there, start rating it out. I will guarantee you that 99.9% of the time, whatever happened in the atrium is not the issue. Okay? There's something else that led up to that. And that always comes out. And it may happen 2 weeks ago, may happen a year ago. It was just kind of the final straw that happened in the atrium. Okay? So to isolate the problem or the issue, that's the hard part. If you always look on the surface, two guys fight. I mean, kids fight. Yeah, you know, the boys, the whole thing, whatever. You'll find that it was probably, you know, grade 3 by the monkey bars. Time he got pushed, smashed his head. He just had enough. So grade 11, he finally snapped. Okay. He snapped up. You threw a French fry at him. He's like, hey, that's it. No more. Now, the more complex radical would be the x minus 3. So I'm going to minus square root x to both sides. Yes, you can do that. So then I have square root x minus 3 equals 5 minus square root x. What have I done? I have isolated the more complex radical. Yep. No, you do that. No, you can't just go and minus x because it's held captive in the radical. I am minusing the entire radical. Okay? Good question. Now, root x minus 3. So I'm going to do like I did before. I'm going to square this. You know why? Because it gets rid of the radical sign. That's awesome. But you have to do it to both sides. That means you take the entire sign. Now, please don't write 25 minus x on that side. That is bad. Okay? This means 5 minus root x times 5 minus root x. That's what that means when you square that one side. It's not, you just don't, that's a no, okay? You don't just distribute it, okay? That is, besides the negative not getting into brackets, number one, the second most common mistake in high school math. People want to go and distribute the squared. You can't do that. So this is x minus 3 equals, now we do this, that's 5 squared. 5 squared, right? Which is, can I write 25 without losing anybody? Okay, 25 minus 5 root x. Then I'm going to do the other one, minus 5 root x. And then negative root x times negative root x is positive x. Okay, so I'm just going to do x minus 3 is 25 minus 10 root x plus x. Okay, again, if you have any questions, just go like this. I'll stop. Okay, now, what's the second thing you now do? Isolate the radical. If I isolate the radical, then I can square both sides again and get rid of it. There's no other way to do this one, but you have to. So what's nice is I've got an x. If I minus x here, see where I minus x? I'll do it in red because I want to get it out of there, right? Minus x, those are gone. Okay, that's nice. Now if I minused, I'm going to minus 25 to both sides. So I will get negative 28 equals negative 10 root x. Okay, I just kind of cleaned up a big mess there. Okay, then I'm going to divide both sides by negative 10, right? So that's negative 28 over negative 10. The negatives cancel, and you can also reduce that. 28 over 10, that's 14 over 5. 14 over 5 equals square root x. Okay, Now I've isolated the radical. So now I square both sides, and I'm going to find out what x is. 14 times 14 is 196, and 5 times 5 is 25. So you get 196 over 25 equals x. Maybe. Okay? So you always have to verify. I wonder if one of these will be on the written response on the exam. Okay? So check it, verify it. So I get square root 196 over 25 plus square root 196 over 25 minus 3. That's supposed to equal 5. Remember, look at the original question. Well, square root of 196 over 25, that's 14 over 5. So we're kind of even going back to something we had before. And when you take 196 minus, and now minus 3, that's the same thing as 75 over 25. After you do that, you'll get plus 11 over 5. This is supposed to equal 5. What's 14 plus 11? See, you have common denominators, so it's pretty sweet. 14 plus 11 is 25 over 5. Does this equal 5? Yeah, 5 equals 5. So x equals 196 over 25 is the solution. Okay, so there's two things we did today. First of all, the first one was domain, or the restrictions. Find out what are the restrictions. And the second thing we did is go solve them and test your solution to see if it's right. Okay? So it was really valuable for the other students to get working on this because they got it after a couple questions. Because by watching me, some of you are still confused. When you start to do it a little bit, you'll get it. Okay? And if you're still not getting it, come up. So 1 to 8, omit 7. Remember, number 1 says determine the restrictions. So don't spend a half an hour trying to solve those. They're easier than that. Just remember, if they're both going right, take the more right. If they're both going left, take the more left. If they're saying, hey, between here and here, just shade in between here and here. So draw a picture. It's much easier to understand.